Hey, you are welcome. This is the third video of one concept one video series. As I said earlier, you will get one conceptual video in every week. So to be a part of this program, please join our channel, and to get updates on new videos, please press the bell icon. Watch the video with patience for better understanding. And today's topic is regioselectivity in Diels-Alder reaction, mainly focusing on Danishefsky's Diene. So before going to Danishefsky's Diene, first we will see how the frontier molecular orbital helps in the regioselectivity, helps in the Diels-Alder reaction. So here is the molecular orbital diagram of Diene and dienophile. So this is the Diene molecular orbital, and this is dienophile. So Diene will have four molecular orbital, that is psi1, psi2, psi3 and psi4, whereas the dienophile will have two. These are pi and pi star. Now there is two type of interaction may takes place here. That is the HOMO of the Diene, that is psi2 and psi star interaction may takes place, or there is the LUMO of the Diene and HOMO of the dienophile, that is psi3 and pi. Now you can see here that the energy difference between the psi2 pi, that is the HOMO of the Diene, and the LUMO of the dienophile is much smaller than the latter. So this interaction will probably takes place in Diels-Alder reaction. Now we'll have here one thing is important, that if a electron rich group is attached to the Diene, then there is an increase of HOMO of the Diene, which actually decreases the energy gap between the psi2 and pi star. So the activation energy requirement will be lesser, rate of the reaction will increase in that case. And the same thing happens when the electron deficient group is attached to the dienophile. That time the energy of LUMO of the dienophile will be lower. Now we'll come to a new terminology, that is synergistic Diene. So which is synergistic Diene? Synergistic Diene is a Diene in which a pulsar effect group will be attached to that Diene, so that it will increase the rate of the Diels-Alder reaction, and the reaction will takes place even in absence of any Lewis acid, and also takes place in low temperature, and it also increases the regioselectivity in Diels-Alder reaction. So such type of synergistic Diene is the Danishefsky's Diene. The Danishefsky's Diene is in which there is a methyl group, there is a methoxy group, and there is a trimethyl silyl oxy group will be attached in this Diene at 1 and 3 position respectively. So this is, as you can see, both are pulsar effect and reinforces each other. So this Diene will increases the rate of the reaction. Now we will come to the regioselectivity of Diels-Alder reaction. So here is an example. Let's say this is the Diene and this is the dienophile. Now two types of product may formed here depending on the orientation of this dienophile. So this is the 1,4 product and this is the 1,3 product. Now which will be the major product we have to determine here. Now in this case we will see how a Diene reacts with an electrophile. Diene is electron rich, so obviously it will react with the electrophile. Now with a pulsar effect group, the Diene will react in this way. On the other hand, dienophile, in which a electron withdrawing group is attached, will react with nucleophile in such a way. So the atom in which this nucleophile is coming is highlighted with green, and here also this atom in which the electrophile will bonded is highlighted with orange. Now the reactions between Diene and dienophile is such type of reaction like electrophile and nucleophile. So the reaction will take place between this carbon atom, and a bond will be formed. So the regioselectivity leads this 1,4 product. I will draw a summary here. that when a group is attached at 1 or 3 position of the diene, or one, this is also we can numbering as 1 and 2, that is 1 and 2 position of diene, a Placer effect group will leads to either 1 2 or 1 per product. So the when the group is at 2 position, that is the 1 per product will be major product. When it is at 1 position, then the 1 2 product will be the major product, but the 1 3 product will not formed here. Will come some example of Danishefsky's. Now Danishefsky's reaction, we will come to some example with the diene, Danishefsky's diene. Now this Danishefsky's diene will have one trimethylsilyl oxy group at 3 position and one methoxy group at 1 position. So these two groups will reinforce each other and it will increases the rate of the reaction. That's why we generally use the Danishefsky's diene in Diels-Alder reaction, and it will also increase the regioselectivity of Diels-Alder reaction. Now this diene will react with this alpha beta unsaturated aldehyde in heating condition. A Diels-Alder reaction will takes place. This reaction is somewhat Michael Addison type reaction, and this is 1 to 1 per Addison type reaction, 1 2 3 4 1 per Addison type reaction. Now then it will finally leads to a cyclic product. Now when it will be hydrolyzed, it will give the final product this. I will come to the second example. This is also with Danishefsky's diene. In this reaction, here there is a sulfoxide group is attached with this dienophile. Now as two electron withdrawing group is attached with this dienophile, so this is a very activated dienophile, and now this such type of 1 4 addition will take place like Michael addition, and then finally a cyclic product will be formed. Then again a sine elimination reaction will take place with the help of sulfoxide, and then this SOH. I will draw the mechanism when this Danishefsky's the product with Danishefsky's diene when treated with SOH or in acidic condition hydrolysis, what will be the final product, that I will draw later. Now we'll come to the example 3. All these examples are taken from modern organic synthesis by Carruthers. You can see there. Here the dienophile is an aldehyde itself. So in the regioselectivity is governed by these two group, and due to this Placer effect, obviously this carbon will connect with this carbon, and finally this cyclic compound, heterocyclic compound, will form. Now there is another two example here, you can see there. Now I will come to an example with Danishefsky's diene, which came in GATE 2021. So the major product formed in the following reaction. So as you can see that we already discussed that reaction in example section. So the orientation may be of either A type or B type. This A type will leads to the product A prime, and the B type will leads to the product B prime. Now which will be the major product? So you can easily determine the major product because due to the Placer effect of this methyl, it will obviously attack in such a way. So this this product will be formed here. This product will be formed here, which on hydrolysis, I drawn here the mechanism of hydrolysis. So here the OMe group will be protonated in presence of acid, and the Plasar effect of SiOMe3 will help the leaving of MeOH, and finally this will leads to hydrolysis, forming the alpha beta unsaturated ketone with CN. So the product will be here C. So guys, if you have any doubt with this video, please let me know in comment box, and to get more interesting video, please subscribe my channel. Thank you. Have a good day.